look here, right? So for vectors, we need to remember that we can represent a vector by writing x and y vertically or write a direction vector. So this x has a direction vector I, and this y value has a direction vector g. What's a direction vector? Well, a direction vector is basically a unit vector in the direction given. So I is in the direction x, and it's a unit vector telling you that you're moving in the x direction. What's a unit vector again? A vector whose magnitude is 1. All right, so that was the form 5 part of it, right, where everything was in 2 dimensions. Now we should reach everything is in 3 dimensions. So all we did is we just add on, instead of an x and y value, we add on an x plane. Right, so a point in here will have an x, a y, and a z. So for example, that point P has an x, a y, and a j, and the corresponding unit vectors are I, j, k. K represents the z direction, j, y, I, x. Please remember, if you have OP, then PO is what? Opposite, but change the signs, right? All right. Next, how you find the magnitude? Square root of x squared plus y squared plus z squared. Right? So if A is a unit vector, how do we find unit vectors? Probably write this one down. To find a unit vector, you take the vector and divide it by its magnitude. All right? And remember, its magnitude is always 1. So please remember that I, j, and k, just make a quick note there. I, j, and k, their magnitudes are 1. Next, equality of vectors. How do you know if 2 vectors are equal? Well, if I told you A and B equal, whatever in front of I should be equal, whatever in front of J should be equal, whatever in front of K should be equal. Okay? That's the only way 2 vectors should be equal, right? Coefficients of all the unit vectors should be the same. All right, nice. So that's just to show you how to compare them, right? A and D and B and E and C and F should be equal. How you add vectors? Add the x, add the y, add the g. Remember, addition and subtraction of vectors will give you back a vector. Don't forget that. Subtraction, same thing. Subtract the x, y, and the z. Here we have a quick example. Let's try it now. A is this, B is this, and C. Let's see if we can find C. Remember, A is 3, 0, minus 1. B is what? B is 2. So add it and you will get C. 5,
6 minus 1.
Very good. Right? 5 minus 6 minus 1. Next, how you multiply? Right? But if you have to multiply by a scalar, you multiply it by each one of these. So Ka will be Kx, Ky, Kz. But when you multiply 2 vectors, you get your dot product. And I want you to remember this. Alright, I'm going to show you the long way here. Watch this here. If you have to multiply A by B, you're multiplying AI by DI. That will give you ADII. A quick question. Anybody remember? I and I are parallel, right? When you multiply 2 parallel vectors, what you'll get? When you multiply 2 parallel vectors, you end up with the magnitude of the vectors. So the answer will be 1. I by I is 1, J by J is 1, K by K is 1. But I and J are what? Perpendicular. X and Y perpendicular, right? So therefore their dot product is 0. Okay? So if you look at multiplication here, I by J is 0, I by K is 0, I by I is 1, J by J is 1, K by K is 1. So in short, you multiply the i's, you multiply the j's, and you multiply the k's. And then add up the answer. Notice it is no longer a vector. It is now a scalar. Let's try this here. I'm trying to multiply these 2 vectors. So if you're multiplying these 2 vectors, 2 by 1, 0 by minus 6, minus 4, 2, you multiply the x by the x, multiply the y by the y, multiply the g by the g. Then add it up. It is no longer vector. It is now a scalar. Right? And you have your I by j, g by k, I by k is 0. Next, displacement vectors. Right? Displacement vectors is where you have to find the alternate root for unknown vector. So if you look here, how do we find AB? Look at the triangle and find the alternate root from A to B. So you start at A, you go to O, start at O, go to B. So it's A to O plus O to B. Then add it up. Remember the line on top shows us a vector, right? Right? How would you find, let's say C is a middle. Here's half and half. How you find it OC? Right? Draw a line from, so you can find O to A plus A to C. Or it could be O to B plus B to C. Anyone can do it. Again, everything is going to be in 3 dimensions. All right? Quick rules. Write this one down because we can do a few like this. Right? How do you find the angle between two vectors? You multiply A by B and then divide by their magnitude and then find cos inverse. Write this down. If theta is 90, then the perpendicular, so the dot product is 0. You all seen why? Cos 90 is 0, so it means the numerator is 0. If theta is 0, then the vectors are set to be parallel. And it means that the dot product is equal to a product of the magnitude. Okay? And the next thing in red there, parallel vectors, they are multiples of each other, or the dot product is equal to the product of the magnitude. All right? So that is the foundation of vectors that we're supposed to have an idea of from Form 5. So we're going to do a couple of these just to refresh ourselves, and then we are going to target the new stuff. All right. So here we have two vectors. Do me a favor, find the angle between them. So when you multiply, the dot product was 9, the magnitude was root 14 and root 13. When you work it out, you end up with 64. It was in degrees, right? Maybe in radians, you got 1 point something. Try this one here. How to turn this into a position vector? Right. OP is equal to 3 minus 2, 1. Right? So I like to work it out like this first and then write it like this. Oh yeah, that's, and I forgot the arrow. The arrow shows up the vector, right? Go ahead. Work out this. All right, nice. So they gave us here, they gave us OP. OP was 3 minus 2, 1. OQ minus 1 lambda 5, and OR was 2, 1 minus 4. They want us to find PQ. So if you want, you can set up a little diagram. It doesn't have to be perfect, right? Here's P, here's Q, here's R. Right? Let's pretend that's R, right? Mightn't be accurate, but just to show you that PQ, P to Q is P to O, O to Q. Right? P to O is negative 3, positive 2, minus 1. O to Q is minus 1, lambda 5. Do we have to find for lambda? Oh, second part. So when you work this out, you'll end up with minus 4, 2 plus lambda 4. But they want the answer in the next form. So that will be minus 4i plus open brackets 2 plus lambda j plus 4k. Right? That is your PQ. What they want after, they want QR. Same principle, Q to O to R. So that'll be 1 minus lambda minus 5 plus R. R is 2, 1 minus 4. Right? So we're going to get what? 1 plus 2 is 3I plus 1 minus lambda J minus 9K. And then last one is what? Last one was RP. RP. So that'll be R to O plus O to P. R to O, that would have been minus 2 minus 1, 4. OP, that would have been 3 minus 2, 1. When you add it up, you'll get I minus 3J plus 5K. So now they said that the triangle, QR is a right angle with side PQ being the hypotenuse. They want us to find lambda. So what does this say? This says that PR and RQ are what? Right? So PR is perpendicular to RQ. So again, if two vectors are perpendicular, then the dot product is 0. So let's go to PR. PR was RP. Right. Actually, I should have written it like this. RQ, RP. Dot product is 0. Okay? RQ, RP. The vector is at R. So RP, we have it there. 1 minus 3, 5. RQ is here. So this is QR, right? This is QR. So RQ will be minus 3. A change in the signs here. So that will be lambda minus 1. Minus 9 becomes positive 9. So therefore, this by this is equal to 0. So I can work it out now. Minus 3 by this. 5 by 9 is equal to 0. Multiply it out, you'll get minus 3 lambda plus 3 plus 45 is 0. Do your thing, can cancel off there, and you'll get minus 3 lambda is minus 45 lambda is. This is minus, this is plus. Yeah, plus 15. All right. So what we've been doing all the time, right? We have been finding the location of a point. So all the time, we have been taking a point, right? And giving it the vector of that point. So to locate this point, you have the x, y, and z value. And to obtain the vector, we drew it relative to the origin. All right. Now we are going to combine a whole set of points that give us a what? A line. Right? So we're going to try to figure out now how to get the vector of a line. So everything here that we've been doing, we have been doing it for points. Now we're going to try to get it for a line. All we need are two things. By the way, how do you find the equation of a line? Y is mx plus c. So to find a line, what you need? You need to know how much its slope and the y-intercept, right? So you need those two important things. Some to tell you direction and some to tell you the exact location. That makes sense? We do the same thing with a vector. We need something to tell us the direction and something to tell us an exact location. Right? So the equation of a line are too important. I want you to remember it like that, right? So you don't go and try to memorize the Cartesian equation or the vector form. Try to remember what you need to get, right? All you have to get is a point on the line and a direction vector. The direction vector is a vector parallel to it, right? So if the point on the line is P, the vector equation of a line is simply the point plus the direction vector by some constant. This constant is because parallel vectors are multiples of each other. That's okay? So once you have a point on the line and a vector parallel to it, you have the equation solution. So we are trying to get the vector equation of the blue line. Just draw the diagram and I want to explain how we get the vector equation of the line. Let's start. So I gave you a point on the line A and I gave you some moving or some random point R, right? So AR will be AO plus OR. AO is minus A plus R, and then B is a parallel vector to AR. So you can combine it and find R. Yes, that didn't make any sense. What you see here? Right. This is the line that we're trying to get the vector equation of. Okay, we're trying to get the equation of this line. So in order to get it, we need two things. We need a vector parallel to this line. Let's call that vector B. We need a point on the line. Let's call it A. If we have a point, we can find the position vector, small a. Remember that? And then the equation will be in terms of R. R is technically any point on this line, right? R is any point on this line. So the position vector of R will be small r. So how am I going to get the equation of the line? To get the equation of the line, we said AR is A to O plus O to R. A to O is minus A because we're going against the arrow. O to R is the vector R there. Are you okay with that? But remember, AR is parallel to B, correct? And parallel vectors are what? Parallel vectors are multiples of each other. So therefore, AR is some multiple of P. So let's call the multiple lambda. That's okay? So it means that we could easily find for R. R is equal to lambda B plus P. Well, pointers come first, right? A plus lambda B. That is your vector equation of a line. Right? Actually, prefer you copy this one, right? Right? Now we're going to take it from here now and give you all the other forms. This is vector form. I'm going to give it the Cartesian form and I'm going to give it the parametric form. Okay? So first thing first, we said that R was any point on the plane. So R is X, Y, Z. Right? Any point on the plane. We said that A was some random point. So let's call the point A, B, C. Okay with that? Right? And then, actually, let me call the vector equation of the plane. Let's call it alpha, beta, gamma. Let's call here X1 because it's one of these, right? X1, Y1, C1. All right? So we're going to get parametric form first. Parametric form is where we're going to write X, Y, and Z in terms of some variable. All right? Real simple. X, Y, Z is equal to X1, so I'm multiplying out this. Right? So I'm multiplying this out, alpha lambda, beta lambda, gamma lambda. Right? And then we're going to add everything up. So you'll get X, Y, Z is equal to, add everything up, X1 plus alpha lambda, Y1 plus this, and Z1 plus this. This is your parametric form, right? X in terms of this, Y in terms of this, Z in terms of this. So X is equal to X1 plus alpha lambda. Y is equal to Y1 beta lambda z is equal to z1 plus gamma. Well, okay with this? Right? Let's put some numbers into it real fast. If we had 2, 1, 4, 0, minus 1, 3, right? If we had these numbers, then the parametric will simply be what? Shavish, what would it be? What would it be? 2 plus 0 lambda, 1 minus lambda, 4 plus 3 lambda. This is your parametric, x, y, and z in terms of lambda. Right, how do I now get the Cartesian form? The Cartesian form has no lambda. What would I do? Divide now. Can I divide by lambda? Also, your lambda there. Can I make lambda the subject everywhere? If I make lambda the subject here, what will I get? X minus x1 over alpha. X minus x1 over alpha. If I make lambda the subject here, what will I get? Y minus y1 and then what? Over beta. Come on. All right. So now that we know what lambda is, we can say, we can equate them, and they're all equal to lambda. So we will get x minus x1 over alpha, y minus y1 over beta is equal to z minus z1 over gamma. This here is your Cartesian. Right, so we have to be able to go from one form to the next. How do you remember? Cartesian form has no lambda. So you have to make lambda the subject and equate. Parametric form has lambda. So you have to make x, y, and z subject. And vector form is the next one. So you have to remember each one of these forms, right? Start with the vector, then make x the subject to give you the parametric, then make lambda the subject to give you the Cartesian. Alright, one for the road here and we're done. Find the vector equation of the line there. All three forms. Right, so first thing first, we have the vector form. Everybody okay with that? According to the information here, P was the parallel vector there. So that's the reason why I put P here. Right? And A is the point. So A goes here, B goes here. And all it will finish. So you write it vertically first, and then you make, and then you multiply it out. Right? And you end up with x is equal to 2 plus 2 lambda, 1 plus lambda, minus 3 minus lambda. What's the next step, Shivish? To get Cartesian, make lambda the subject. When you make lambda the subject, you will end up with x minus 2 on 2, y minus 1 on 1, minus 3 minus z on 1.